Example problem 1 asks us to calculate the normal, maximum, and minimum powers of the human eye. The first thing we're going to calculate is going to be the maximum power, so P max. And the formula for P max is 1 divided by the near point distance for the average human eye plus 1 divided by the lens to retina distance. So from the front of the eyeball to the very back of the eyeball in the average human eye. So going back to the previous slide, we can see that the average eyeball has a near point distance of about 20 centimeters. So an average near point distance of about 20 centimeters. And then we need that lens to retina distance. So a normal human eye has a lens to retina distance of about 2 centimeters. So that L to R distance is about 2 centimeters. So we're almost ready to put this in the equation. We have to convert these to meters. So centimeters goes to the bottom, meters goes to the top for both of them. Giving the 1 to the things with the prefixes and the metric system constant for centi, which is 1 times 10 to the minus 2, to the base units, which is meters. And you can see where centi cancels. And you're left in meters for both of these. And so 20 centimeters, so 20 times 1 times 10 to the minus 2 is going to be 0.2 meters. And then on the bottom, 2 times 1 times 10 to the minus 2 is going to be 0.02 meters. Now we're ready to put this into the P max equation. So P max equals 1 divided by the near point distance of 0.2 meters plus 1 divided by the lens to retina distance of 0.02 meters. You can put this all in your calculator at one time. It doesn't need to be in multiple steps. And when you put that in your calculator, you'll get 55 diopters for P max. Now we need to calculate P min. So the problem also asks us for the minimum power for the human eye. And the formula for P min is 1 divided by the far point distance plus 1 divided by the lens to retina distance. The assumption for far point is that it is positive infinity. So the far point distance is going to be positive infinity. So when we put this into our equation, it'll look like 1 divided by infinity meters plus 1 divided by 0.02 meters. We can't do anything with this mathematically, so putting it into your calculator, you're going to ignore it. The only thing you're going to need to do to calculate P min for the normal eyeball is divide 1 by 0.02 meters. And the answer to that is going to be 50 diopters for P min. Let me know if you have any questions about example problem 1.